Hello, welcome to the Gio 2021 May Community Call. Well, kinda. During the actual community call, we had a problem with our meeting platform. Their recording functionality was broken. So, what you're watching now is a reenactment of some of the presentations from that community call for people who weren't able to make it there. But if you were there, this might not be exactly the same. Elias spent the last month working on the compute shaders CPU fallback functionality, trying to optimize that so that we can achieve good performance on platforms that don't support the compute backend. Additionally, he spent a lot of time working on functionality for blending Gio with other GL technologies like OpenGL. If you want to check that out, you can look at the gioui.org/example package. There's a new example called OpenGL that demonstrates how to do that blending using the new tools. In the last month, I implemented the material design tooltip component, and later on, I'll be talking more about that. But Vladimir Magyar, I hope I pronounced that right. I'm sorry if I did not. Has implemented a package called rich text, which landed in GeoX in the last couple weeks. And this package allows you to lay out runs of text with multiple styles. You can have different colors, you can have different fonts, different font sizes, and that has unlocked a lot of potential. The rich text package is not done. It's 100% not stable. We already know some features that we want it to have that it doesn't currently surface, and those may require breaking API changes. But it does exist, and you're welcome to check it out. So I have been building atop what we already have there to implement some basic Geo markdown support. This is what that looks like right now. So you can see here, we have an editor widget on the left and kind of a preview pane on the right. So yeah, there's text. That's so very exciting. But we have exciting text like italics, bold, monospace text, and even if I can type, more than one of those things at once. We also have support for bulleted lists, numbered lists, and you can see here that the numbering is actually inferred correctly, even though I just used two ones. We have many different size of headings. Whoops. And of course, the big ones are big, but like really big. We have code blocks. Now, no syntax highlighting right now. That's a fairly complex endeavor, but it's possible in the future. And I know that this gets us pretty far, but the feature I am most excited about is this one. Just like that, we have clickable hyperlink capability. So thank you so much, Vladimir, for the rich text package. You can see it's just so satisfying to be able to do this finally. So this markdown program is not yet done either. It has some issues to support even just advanced use cases of these features. It needs more work, but it's coming. You can find my work in progress in the GeoX repository on the Markdown branch. but that is definitely 100% certain going to go through breaking changes soon. So I would not build your project on top of that right now. But yes, this is what I've been up to for the last month. Hello. Today I'm here to talk about best practices of designing components with Gio. This is a joint presentation between myself and Jack Mordaunt. His part's going to follow mine. First, I have to say that nothing I talk about has anything to do with my current employer. The views are my own, all that jazz. But also, I want to be clear that this presentation is going to present some models for how to think about designing components in Gio. But they're just models. And we should all remember that all models are wrong, but some are useful. And Jack and I think that these are useful. So first of all, let's clarify what I mean by a component. Component is a building block in graphical user interface design. As Gio stands today, we have a bunch of things that may or may not be called components, that they live in the widget material package, the button, the editor, those things. Material design calls all of those components, but within Gio, we typically refer to them as widgets. I kind of use those words interchangeably throughout this talk. A component is a widget, but many of the components that I've ended up building are composed of multiple Gio widgets working together. For instance, my color picker implementation has multiple editors and sliders that interact. So today I want to study in detail the design and implementation of the tooltip component that material design specifies. The tooltip is a very simple component. It's just this little thing that shows up when you hover over a control. Here's one right now, the toggle reader view. We're used to seeing these, and material provides some spec for how they should work and what you should not do with them. And down kind of at the bottom, they need me to zoom out. They provide some specifications for how big they should be on desktop and what the font size should be on desktop and how that should look on mobile. So what we're going to do is we're going to kind of distill the requirements a little bit for the sake of simplicity. We want to make a rounded rectangular background that displays some contextual help text, and it should fade in and out in an animated fashion. And so I have made a bad tooltip implementation. And what I mean by bad is really, this is how I would have done it a year ago. When I was very new to Gio, I was very new to immediate mode design, and I didn't yet have some of the structured thinking I do now. So I want to walk you through a potential implementation of the tooltip that way, and then talk about some principles that I think help, and then show you the actual tooltip that I've merged, and talk about that. So over here on the left, we have my bad tooltip code. It's a structure that has some content, that string that it's going to display. It has a reference to the theme. It has some state. Basically all of these last four fields have to do with the animation state. Are we animating? Are we appearing or disappearing? Are we currently visible? And when will the current animation finish? So you can see that we create a new tooltip by giving it a theme and the text, and then we're just going to allocate that. Let everything else use its 0 value. We've got the duration of the animation here as a constant. And so using this tooltip is very simple. We just call its layout function. And layout first checks for pointer events in kind of the contextual hit area. So if someone starts hovering, we want to know. So that's what this block does. And then we want to check whether we have just finished an animation or not. And if we have, then we want to update some state about whether we're appearing or disappearing. And then if any part of us is visible, either because we're fading in, we are fully visible, or because we're still fading out, then we actually have to draw a rounded rectangle. So we're going to grab our foreground and background colors from the theme, and then if we're animating, we're going to interpolate the current value of those colors. And then finally, we will actually lay out in a stacked fashion that rounded rectangle and then the text on top of it. So it's very straightforward as such things go. And then finally, we declare that pointer hit area. So using this tooltip, looks like this. We allocate a new tooltip using its constructor. And then when we actually want to show it on top of an icon button, we use a layout.stack to put the icon button and then the kind of context hover area for our tooltip. So let's see what this looks like. So we have this button, and then we hover over it, and voila, text fades in and fades out. Great, right? It works. It's done. But this implementation has some problems, and they may or may not be apparent. So let's pretend that instead of declared in this file, what if this tooltip was, in a package, like their component package, and you actually wanted to change some things about it? Let's say that your app in your kind of material theme doesn't use rounded corners, or uses very rounded corners on rectangles. If we wanted to change that, we can't. And the reason we can't is that the degree of roundedness of the rectangle is hard-coded within the layout function. It's just not exposed to us. Similarly, if we want to change the background color, the way that we go about doing that, because the theme is retained here, we need to take the theme pointer or the theme that this points at and edit its foreground and background color properties, which is just like kind of cumbersome. And what if we wanted to change the duration of that fade animation? Well, that is also hard-coded. Not to mention, if we wanted to change the padding or the margin within, or the positioning of the tooltip relative to other content, all of those properties are actually really difficult to adjust with this design. So there are some things that we can do differently. And they have to do with avoiding a set of problems. Those problems are, this widget is a retained mode widget. We're an immediate mode UI, sure, but the way that we built this here, it retains everything across frames. It retains a pointer to the theme across frames. It retains the string that it's going to display as the tooltip across frames. So if we wanted to edit the theme, we have to edit this persistent theme that we used when we instantiated it once, as opposed to a theme that we give it every frame, so that if we updated that the next frame, it would change. This widget doesn't let us change all of those properties we talked about. It's a very inflexible implementation. And so we should refactor this. We should do a better job with this code structure. And here are 4 kind of rules of thumb. They're not laws, but they're helpful, we think. The first one is thinking about your state. So you have core states, which is like what's defined mostly in the Gio widget package. Is this checkbox checked? What is the current contents of the edit buffer of this editor? That sort of kind of fundamental state that has nothing to do with the presentation of a thing. Like a checkbox is a Boolean, and so is a little switch. And Gio recognizes this. We have the widget.bool for expressing things that have a logically Boolean state, regardless of how that Boolean state is presented. That's what core state is. But there's also ephemeral state. I'm jumping to the third one here, which is what information we need in order to present the widget. Colors, sizes, ratios, padding, all of that information, animation, timing, that sort of stuff all needs to be available to us when we go to lay out this widget, but it's not necessarily needed across frames. In fact, to get all the advantages of the kind of fluidity of immediate mode, where we derive these properties every frame so that we get responsive UI by default, you can't retain the ephemeral state. And then there's this kind of awkward state where if you're doing animations, especially once they start to get kind of complicated, you need to keep track of how far through an animation you are. You need to keep track. The widget.clickable retains not just whether it was clicked, but a history of recent clicks and their locations within the clickable's boundaries. And the reason for that is because the material button inks itself. It has this little animation of a circle expanding from the click location. And more than one of those could be expanding at any given point of time. And this is an example of this kind of transitional state. It's state that we need, but we need it in order to present the widget within a certain theme. The material theme and the way that their buttons ink, yeah, it requires that. But if you were implementing a different UI theme, you might not need that. The history of the clicks might be irrelevant because the button will never be in a state where it's animating multiple past clicks at the same time. So because of that, we call out that this is a different state. And ideally, this kind of transitional animation state would be persisted in a different type, or at least kind of factored to be separate, so that the core state widgets can be reused as widely as possible. The second thing is you should strive to compose your components. And what I mean by this is that often the responsibilities of a component don't all have to get bundled together into one thing. So this tooltip, it displays some information, it animates, and it, triggers on this hover, or if you read the spec, it also triggers on long press. There's actually quite a few behaviors here, and you can build all of them into one thing, but you don't actually have to. And if you separate them, you can end up with some nicer code and potentially more reusable code. The third is that the widget interface is your friend. Work with it. If you can build types that compose using, sorry, I misspoke. It's not an interface. It's a type. The widget type, the function that accepts a layout.context and returns a layout.dimensions. That type is crucial for Gio's ecosystem, because if you accept instances of that type and work with them, you enable transparent composition across the entire ecosystem. I can build components that fit right into your layouts. But it's often tempting to not do this because we want to be able to provide more data. We want to add parameters to our interface, or there's a number of different reasons, and some of those are really valid. But I can't overstate that when you have the opportunity to accept a layout.widget, or you have the opportunity to accept a concrete type, you should have a strong bias to just accept layout.widget. It will make your types more useful and more reusable. And then finally, this one is one that maybe took me the longest to figure out. You want to compute all of the ephemeral state that you can inside of the construction of your ephemeral types. So our tooltip here, its constructor does almost nothing. And then we choose our colors and we choose our positioning and our text properties. All of that happens inside of the layout function. And this deprives users of the tooltip of the opportunity to change any of those properties that they want to. If instead we promote this information to be fields available on the tooltip kind of ephemeral state, and then we provide a constructor function that creates that state, and then the user, the consuming code, has the opportunity to adjust the values of those fields before they lay it out, we give them the flexibility to change all this stuff. We let them change the padding, we let them change the font, we let them change all of it very easily. And that's really valuable for making your components actually flexible enough to fit into somebody else's UI and the way that they're trying to design things. So with all of that said, what does the tooltip look like? So here's the one that I've actually got in component right now. So you can see right off, we have more fields here. And what they do, the inset defines, the inset here defines the padding inside of that rounded rectangle, giving the consumer control over that. We have the corner radius as a property that you can adjust. We actually are composing another ephemeral state here. We're composing with the material.label style, which lets other code adjust all of the properties of that text presentation by working against a type that they've already worked with. The material.label style is very common. And that does capture the string that is going to be laid out, but it also captures the colors and every other facet of this design. And finally, the background color. The foreground color is encapsulated within that text field. And then we provide some constructor functions that let you instantiate the tooltip. And note that they have the same signature that they had before. They still accept a theme. They still accept the text that you want to lay out. But the crucial difference is now here, we use everything from the theme that we need. We pull out all of the data from that theme that we actually need, and then we don't retain the theme as a field. So when we call layout, we are working with only decisions that we made here, only the current values of all the fields in the tooltip. And that means that between construction time and layout time, calling code can change any of it. And that will actually change how we behave at layout time. So there's two constructors, one that follows kind of the mobile tooltip spec and one that follows the desktop tooltip spec. And there's also a platform specific one that's in a different file that uses a build constraint to kind of choose implementations based on Go OS. This is an aspect of the design I'm less certain about. This may change, but it's easy enough to see how it works. We just have two different sets of defaults and then we choose between them, and maybe we'll end up just having a single constructor that tries to more intelligently choose. So what does laying a tooltip out look like? It's very easy now. And it's easy because we've also separated the responsibilities. This tooltip is only responsible for presenting a rounded rectangle with some text on it. It no longer animates, it no longer listens to pointer events. Those responsibilities are part of something else. So yeah, this is very simple, and all of the layout here is derived directly from those properties above. So it's really easy to control. The invalidate deadline is a helper that enables us to do animations in the future instead of right now. So the actual material spec says, when your mouse enters an area, it shouldn't trigger the hover text immediately. You need to hover there for a while. And so this lets us easily do things like, I want to invalidate in half a second. And here is the state type for the kind of context area that when you hover it or long press it will present the tooltip. And this is important. This actually implements as much of the material spec as I can. So this is doing more complicated stuff than the other, the poorly made one. It is doing long press detection, it's doing delayed animation, and it's doing some more intelligent positioning of the tooltip. So this is going to be a little bit more complicated code, and that's because it does more. So we have some default animation timing, and you can see that those fields are actually captured here. And then this is what our layout function looks like. So we, as the tip area, accept the graphics context, we accept a tooltip, and we accept a widget. So I really wanted this to work as a layout function that accepted two widgets. One of them, the thing that would show up when you hovered or long pressed, and one of them, the thing that you hover or long press to make that happen. But unfortunately, we need to be able to modify the tooltip's foreground and background color based on the kind of animation state. And that requires us to know about the tooltip's foreground and background color. And the cleanest way I found to do that was to directly accept the tooltip ephemeral state type here. And then we can actually modify its foreground and background color to fade it in. In the future, Gio may actually get a opacity op, where you can say, hey, make things rendered after this point, or at least until the next stack op, or what are they called now? Save and load. Until the next time the graphics context state is reset, make everything 80% transparent. And if we had something like that, then yes, it would be easy to make this work with 2 layout.widgets instead. So we make sure the 0 value is useful. And then we check our pointer events, and then we detect the various animations that we might be triggering. And then we lay out our context area. And the content that we're laying that context area out on top of. And then if we are visible, if any part of the tooltip is visible, either it's fading in or it's visible or it's fading out, then we actually lay the tooltip itself out using a defer op. And then finally, as a convenience, I implemented a tip icon button style that takes a tooltip, ephemeral state, and the icon button style state that's also ephemeral state, and that's right out of the material package. And then the state for one of these tooltip areas, just a reference to it. And that handles fading. Well, that handles configuring the tooltip for that icon button in a fairly easy way. So what that looks like in practice is we define a tip area here on line 36, and a clickable state and some ops. And then at layout time, we say, hey, tip area, would you please lay out a icon button and the correct tooltip for this platform as the contextual help. And so if we go that, you'll see the same visual here, but the tooltip fades in after half a second instead. It's intelligently positioned itself at the bottom of the button and centered with respect to that button. It's difficult to demonstrate long press support on a desktop, but it does support that. And so what I think this tooltip achieves is a more flexible and adaptable design that's easier to maintain, easier to reason about, but actually wasn't any more work for me to make. So I would encourage you to think about your own code through the lens of these 4 principles and see whether you can use these as an opportunity to simplify. With that, I'm going to turn things over to Jack. Thanks.
Presentation about Gio state taxonomy, aka how to structure Gio applications well. So in Gio, we have 3 types of state. The first is core state. Core state is to do with interactions. Transitional state is the second kind, that is to do with animations. And ephemeral state is the third kind of state, that is to do with styling. Understanding these 3 states will help you cleanly separate out concerns and write clear, concise, well-structured Gio programs. Core state is about functionality, interactivity. So that's your widget clickable, that's your widget bool, that's your text editor. It is the state required to maintain interactivity over time. So therefore, it must be retained. In immediate mode programs, every frame is the unit of time. And so if you throw out the state every frame, you lose your sense of time. So core state has to be retained somewhere. Now, core state shouldn't handle any visual data. Why? Well, because core state is fundamental to all widgets of that kind. So, for example, all buttons need to track clicks, no matter how they look, no matter if they're even rendered. So if you tie visual state to the core state, you've now coupled two completely unrelated concerns together, making your clickable unusable for differently styled buttons. So core state has no visual data in it, or shouldn't have any visual data in it. This code sample here is an example of the widget clickable with some fields alighted. Basically, you can see that it tracks clicks and it lays out some information to some pointer operations to track clicks over a given region. Next up, we have transitional state. Now, we don't really know what to call transitional state, really. But basically, it boils down to animations. This is state that must be retained over time, because again, animations occur over time. But it's not to do with functionality at all. It's to do with purely stylistic, thematic concerns. So if you are fading in from blue to red, if you are changing sizes, if you're changing any visual parameters over time, this is animation state or transitional state. Now, transitional state, you might say, well, if core state's retained and transitional state is also retained, then why not just tie them together and allocate them at the same time or next to each other? Well, the reason that you don't want to do that is, again, you don't want to tie visual data to interactivity, because then you can't swap out themes. You're coupling them together. Now, it has to be retained somewhere, so this is where theme factories come in handy, which is some object off to the side somewhere allocated on the heap, not allocated by the layout code, that can then reference some stable state, which you can then use to animate. One of the reasons you want to manually allocate core state is because you need the semantics of what it is. If you have two buttons, you can't just arbitrarily go, give me one of the button clicks. You need to know if it's a submit button or a cancel button. So you name it and you put it on a field. With transitional state, this is not the case. Transitional state, it doesn't matter which button it is, as long as it gets mapped. And because it's a theming concern, the layout code doesn't want to have to do that mapping. So you don't want to burden the layout code with this kind of concern. The other thing to say about transitional state is that it's completely optional. You might have a theme that doesn't actually do any transitions. It just has Boolean states, just flips on and off. In which case you don't need to have any transitional state. The third kind of state is ephemeral. Ephemeral means short-lived. And in this context, ephemeral state is state that doesn't need to be retained, and therefore shouldn't be retained. Retaining state that doesn't need to be retained implies that it does need to be retained. And if you manipulate that variable between frames, you've now temporally coupled the frames together unnecessarily. Ephemeral state benefits from being declarative in nature, and it benefits from being deferred until just before the widget lays out. The reason for that is just before the widget lays out, you have maximum context, maximum information about what to do with the widget under what circumstances. So you don't want to make decisions earlier in time when you have less information, only to change that decision later in time when you have more information. As you can see here, this is an example of a style structure that contains ephemeral state. Now, often the style structures get suffixed with the style word to indicate that they are the final element in the layout that brings everything together and renders the final widget. You'll notice that in here, it takes a reference to core state, which is the widget clickable. So this foo style, whatever this widget is, can be clicked and track clicks. This is manually allocated by the layout code and gets passed in to the foo style so it can reference it when laying out. So for example, if your button renders gray, like it changes color when you click it, then this reference will be used in the layout to change the color appropriately. Now the second piece of state here is transitional state. This is a fictional type. It doesn't exist yet. It's a theoretical type. But the idea is that it would track progress of something over a duration. So if your button changes from blue to green over 1 second, the progress here will track that so that in layout, you know how far along that animation you are, so you can interpolate the colors. And finally, we have the actual real ephemeral state, which is not retained at all, and it gets specified at layout time. You'll notice that the foo struct brings it all together, core, transitional, and ephemeral, so that the widget can be completely laid out. This is an example of a program that brings it all together. So we have a UI struct, which has our core state semantically allocated and named so that in our update we can reference them correctly and handle them appropriately. Now in the layout, you'll notice that what we have here is we have a flex and we simply lay these two buttons out horizontally. Now you'll notice that in the layout code, we don't actually have to deal with any animation or transitional state at all. It's completely hidden from us. The colors and the transitions completely hidden. The only thing we actually see is the core state, which we pass in as a reference to the constructor of the theme package. The reason it's structured this way is so that we can put all the theming concerns into the theme package and not have to ever see them again. So we can swap out the theme later on, for example, from a theme that doesn't have any animations to a theme that does, and the structure of the layout doesn't have to change. Now, an example of a theme factory would look something like this. We have our semantic colors, primary, secondary, and text color, which, as you can imagine, could be swapped out or re-specified at any point to change the look of the program without changing the structure of the layout. Now this here is interesting. This is the transitional state. In this case, we have just a buffer of progresses, which, as referenced before, just tracks some progress over a time slice. So we know how far in an animation we are, for example, if we're interpolating between colors. Now this is an example of a style structure for our fictional button. Again, we take the core state, we take a reference to the transitional state, and then we have our specific colors. Now these aren't theme semantic colors, they're specific only to this button. So as you could imagine, any theme could then map from the semantic colors to the button colors. Now this is what makes it a theme factory. This method here returns a button style and brings together all the state to instantiate it. So to keep the API clean, the only thing we take from the outside world is the clickable in terms of state. That's allocated on the UI struct above. And you'll notice, importantly, that this component progress, transitional state, comes from the theme. So we smuggle it in through the receiver. It is retained, but it's never seen by the layout code. This means, again, we could swap in a new theme that doesn't animate at all or does more animations, and we don't ever have to care about it in terms of the layout structure. And then finally, it maps the theme semantic colors to the button specific colors. This is what completes the entire bringing together all the state into one place called the button style, which can then lay itself out as a button in any way it sees fit. Structuring your Gio state like this will make sure that you have clean and well-defined, easier to read Gio code.